So classical theory of heat capacity. Heat capacity. Classical theory of heat capacity. In in classical theory, it is assumed that each atom of a crystal acts as three-dimension harmonic harmonic oscillator, and and all the atoms vibrate independent of one another. Independent of one another. Next, let us assume that each harmonic oscillator each harmonic oscillator vibrates with its natural frequency omega naught. Each oscillator each oscillator may have energy value from 0 to infinity. The energy of 1D or one dimension harmonic oscillator is given by total energy capital E equal to kinetic energy plus potential energy. So capital E equal to kinetic energy plus potential energy. P square by 2m plus 1 by 2 m omega naught square into x square. According to Maxwell's Boltzmann distribution law, the average energy of oscillator is given by e power minus e by k suffix b t. K suffix b is Boltzmann constant into dE by integration e power minus e by k suffix b into t into dE. This is second equation. So this is the Maxwell's-Boltzmann distribution law. According to Maxwell's-Boltzmann distribution law, the average energy of oscillator. Substitute equation 1 in equation 2. Substitute equation 1 in equation 2. So average energy equal to integration P integration X. So here E place, substitute this value, we get P square by 2m plus 1 by 2 m omega naught square x square into e power minus e by k suffix b into t dE by integration P integration x e power minus p square by 2m k suffix b into t dot in capital E place e power minus m omega naught square x square by 2 k suffix b into t into dp dx. Here also we can write dp dx. Integration with respect to p and x. So integrate this equation with respect to p and x, we get integration p integration x p square by 2m dot e power minus p square by 2m k suffix b into t dot e power minus m omega naught square x square by 2 k suffix b into t dp dx by integration p integration x e power minus p square by 2m k suffix b into t e power minus m omega naught square x square 2 k suffix b into t dp by dx plus integration p integration x 1 by 2 m omega naught square x square e power minus p square by 2m k suffix b into t into, here I am writing e power minus m omega naught square x square by 2 k suffix b into t dp dx by integration p integration x e power minus p square by 2m k suffix b into t e power minus m square or m omega naught square x square by 2 k suffix b into t into dp dx. From this we get average energy equal to integration p square by 2m e power minus p square by 2m k suffix b into t into dp by integration p e power minus p square by 2m k suffix b into t into dp plus integration x 1 by 2 m omega naught square x square e power minus m omega naught square x square into dx by integration x e power minus m omega naught square x square by 2k suffix b into t into dx. So formula integration 0 to infinity, integration 0 to infinity u square e power minus a u square du equal to 1 by 4 under root of pi by a cube, comma 0 to infinity e power minus a u square du equal to 1 by 2 root pi a. Next, 1 by 2m into 1 by 4 root of pi by 1 by 2m k suffix b into t whole cube by 1 by 2 root pi by 1 by 2m k suffix b into t plus 1 by 2 m omega naught square into 1 by 4 root of pi by m omega naught square by 2k suffix b into t whole cube by 1 by 2 root pi by m omega naught square by 2k suffix b into t. From this 1 by 2 k suffix b into t plus 1 by 2 k suffix b into t, k suffix b into t. The total vibration energy capital E equal to 3n e bar, because each atom has 3 degrees of freedom. So capital E equal to 3n k suffix b into t. Next one, heat capacity. Heat capacity so C suffix V equal to 3n k suffix b. Here molar heat capacity so capital N equal to sodium, where n suffix a is Avogadro number. C suffix V equal to 5.96 calorie per mole Kelvin. Next diagram. Graph. So this is the graph temperature and C suffix V value. So according to classical theory, this classical theory, according to classical theory, the molar heat capacity, the molar heat capacity, the molar heat capacity of all solids is constant. Is constant. This is called Dulong and Petty's law. This holds good for high temperature, good for high temperature, good for high temperature up to room temperature, up to room temperature, but as T tends to 0, then C suffix V tends to 0. Next, Einstein's theory of lattice heat capacity, or this is also called as quantum theory. Quantum theory. So this is also called as Einstein's theory of lattice heat capacity. Lattice heat capacity. So Einstein retained all assumptions of classical theory except that classical oscillator is replaced by quantum oscillator. So this is quantum theory or Einstein's theory of lattice heat capacity. Einstein retained all assumptions of classical theory except that classical oscillator is replaced by quantum oscillator.